Title tonight is Snow Conditions and Avalanches, and we'll be looking at two case studies. We've got two great speakers as well. We've got Dr. Michael Redding and Mark Diggins. I've worked with Mike all of my career. He joined the Met Office in 2011, and I know from personal experience an expert mountaineer and an expert meteorologist. So it's going to be a great talk. And Mark as well, I've worked with Mark works for the Scottish Avalanche Information Service as a qualified mountain guide. And provides the avalanche observation forecasts for SAIS, which is a real skill in itself. So two really qualified speakers for this, and should be really entertaining. So over to you both.
Thank you. Can someone?
I want to.
Okay, great. Thank you very much for the introduction. It's great to be here. Thanks very much for the invite, and I'm excited to be here because I'm sharing a platform with Mike, and who's going to be on in a moment. And really, what this theme is about is the connection between weather and avalanche hazard, and that's really the theme. And from my perspective, actually, it boils down to almost to crystals and grains, because of how they behave, how they interact, how they grow, how they form layers. And that actually, if you like, is the essence of avalanche instability, but also that is determined by the weather that we get. That's a direct impact on those grains and how they interact with one another. So well, I'll start off with a slide, the next slide. Hang on. We have a technical issue here. Is this on here, Mike? Yeah. Right.
Take that citizen as slide, but we
Is the top is okay with me? Oh, hey. Sorry about that. I'll let this run, and then I'll stop the sound and then talk over it. I'll start again. But technical issue with the sound of the speaker. Sorry about that. So what we're actually going to start off with is a case study, two case studies, and this is the second of those two studies. And really, it's about the impact. And this is the result of an avalanche that took place in the Cairngorms in the Northern Corries on the 6th of December. And we are here on the 6th of December. We're going to wind back the clock in a moment, and we're going to look at the weather, the snowpack development, and all the events and circumstances that lead up to this point. But I think it's really important to understand what the impact is. And this is the impact of someone being avalanched. Lots of people, in this case, the Cairngorm Mountain Rescue Team going out in the middle of the night to actually look after some people. So I'll run this and maybe switch the sound across. Oops. These So. So you can see that this took place in the Cairngorm Plateau in the middle of the night. So the rescue team initially were right on the plateau, and they had to lower somebody down to find the person, and then they took them to the bottom of the corrie and then took them out. So really, it's about the chain of events that lead up to that point. So let's bring Mike in on this one.
Thank you, Mark. Good evening, all. So my name is Mike Redding. I work as a senior operational meteorologist at the Aberdeen Met Office. Now, before we delve into the kind of evolution of the weather that led to the conditions which basically ultimately resulted in that avalanche being triggered, we just wanted to first of all talk to you a little bit about the basically avalanche forecast, avalanche hazard forecast that we're really fortunate to get by the Scottish Avalanche Information Service. So within the UK's mountains, when conditions are just right, then avalanches can provide a really significant hazard up in the hills there. We're really fortunate, as I say, up in Scotland, that the Scottish Avalanche Information Service will provide us with the daily kind of avalanche hazard forecast through the main kind of 6 popular areas of the Scottish Highlands throughout the kind of December through to April. Up in the Aberdeen Met Office, we work in very close partnership with the Scottish Avalanche Information Service. So, as Mark said, the weather and how the snowpack evolves are really kind of quite intimately linked together. So, within the Aberdeen Met Office, through the months of December right through to kind of April, we provide a daily forecast. You can see an example here on the left, which is tailored towards the needs of the avalanche forecasters. So our supercomputer down in Exeter will produce kind of wind speed, direction, precipitation type, and amounts, temperatures, and freezing levels for some of the main summits in the 6 kind of forecasting areas. And our job as meteorologists is to then take this data and scrutinize it. And so we'll be looking at sort of satellite imagery, kind of rain radar, and also using our experience and knowledge of the model's characteristics, their strengths, their weaknesses, and also our experience of previous events to kind of give guidance to the avalanche forecasters on basically what they like to see on the ground. So how well are these models actually predicting the reality? So we send this on a daily basis by about 11 o'clock in the morning, and then we'll also kind of sort of provide the occasional briefings, and we try and give a heads up for any kind of big changes in the weather. So maybe a week or potentially even kind of up to maybe 10, 12 days, even potentially 2 weeks ahead. We can maybe can give a steer to when there's a prolonged kind of cold spell coming. So working really kind of close partnership, and from this information, then the avalanche guys then go out, and I'll let Mark talk about how they produce the hazard forecast.
Okay, yeah, thanks. Yeah, so this is the information we get on day 1, and this is what we produce an avalanche forecast with. So at the top, we've got wind speeds over a 24-hour period. So our forecast will be like 6 o'clock this evening, and then go right through the night till 6 o'clock tomorrow evening. So in fact, we're even forecasting avalanche hazard through the night. And so it may be that we actually have a heightened hazard in the darkness. And the reason we do that is because there might be somebody out at night, there might be somebody late, there might be a rescue team needing to go out into the mountains. So that's really quite important. So what we produce then is from the Met Office. This is the computer generated information from Exeter, which largely is pretty accurate in terms of the information that we get. But any idiosyncrasies or like showery conditions, then that's a bit more uncertain for us in terms of where the showers are going to be and the intensity. So we'll contact the guys in the Met Office just to get a bit more detail on that. Then what we do is we say, okay, we'll produce a forecast. And what we have on the right, that's the sort of illustration of our forecast. We have at the top, can't quite see the color, but that gives the rating out 1 to 5. So that's a considerable rating. And that means that the avalanches are likely. And also what it means is that in terms of going up the scale, it means that actually the likelihood of potentially encountering a place where you might cause an avalanche actually becomes more and more extensive. So you can actually, I don't want to be sort of grim, but you can sort of get avalanche pretty much at any level if you go to the right place. So the likelihood of it avalanching is really dependent on how widespread those potential areas are. And so we'll have that sort of graphic presentation of where the hazard may be in a landscape. And up on the top right, top left there, we'll have what we call the avalanche problems. And there are 5 avalanche problems that we use that are the most common problems that will occur from an avalanche point of view. And those avalanche problems, of which there are 5, are used throughout Europe, same problems. Indeed, they're used in through North America as well. North America subdivided a wee bit and a little bit more, so they have 9, but we have 5. And the main one we are concerned with is wind slab, and also the one on the right, which is something called a layer that's been growing and developing underneath the surface. That's called a persistent weak layer. So we see that there are 2 problems that we have going on at the moment on this forecast. And our job is to say, okay, they're the problems. Where are they? How widespread are they? And therefore that gives us the avalanche hazard level. So that really, in a nutshell, is what we use from the weather forecast that we get from the Met Office team in Aberdeen. Great, thanks. So I'm going to start off now on the 29th of November. We're leading up to that point of 6th of December where that avalanche occurred. So Mike, go on to what's happening with the weather.
Thanks, Mark. So to really understand why that avalanche happened on the 6th of December, we have to really kind of rewind back a whole week to see what was going on. So what we're going to do is just talk you through kind of how it evolved over that period. So what we have here, basically, this is a mean sea level pressure chart you find on our website. And this is valid for midday on the 29th of Wednesday, the 29th of November. Now, what we can see here, probably kind of complex area low pressure that's covering much of the southern part of the UK, northwest Europe. But across Scotland, we can see, so we can see kind of across Scotland, there's basically we follow these little lines here, these are the isobars, the kind of the pressure fields there. And these are really useful because they can tell us where the airs come from. And by understanding where the airs come from, we can understand a bit about the characteristics of that air, what the type of weather it will bring. So we follow them back. So northern hemisphere, so it goes anti-clockwise around the lows. So we follow that across into northwest Russia. So it's originally from a very cold region across Scandinavia, and it comes across the North Sea. So it's very, very cold air crossing the North Sea and gets a bit of heating from below. So North Sea, kind of relative to Scandinavia, is going to be relatively quite warm in November. So that bit of heating just starts to trigger a bit of convection going. We can see on the this image here, this is a radar image taken from about 10:30 in the morning, and we can see there's kind of showers kind of coming in. And they bring kind of basically kind of frequent showers into the east side of the country there. So what I've got here is on the left. Now this chart here is something that we look at. That's our bread and butter as forecasters. Something called wet bulb potential temperature chart. Now I'm not going to go into the details of exactly what it is. Boil all that. But essentially, what it's showing you is I feel kind of this combination of temperature and humidity. The reason these are really, really useful for us as forecasters is they can provide fingerprints as where you find trough and front. So basically, bands of more persistent precipitation. So we can see kind of over Scotland midday, kind of weakening kind of polluted front that's starting to kind of move southwest across Scotland. And so in amongst those showers, we're getting those showers starting to merge together for a time. Bring more persistent precip. And the values there, if you can make it out on the screen, that's +2 degrees. So that's kind of basically easily cold enough to be pouring this snow over the hills. Now what we have as well on the other side there is this is model winds. So the wind barbs or little twig things, if you like, they're basically the surface winds, but it's showing the wind direction. So you see it's coming in from a northeasterly. So that basically kind of so Cairngorms is the first major sort of set of hills that's going to meet. The coloured contours, these are the basically the winds up at 600 meters. So if we recall the incident we were looking at, we're talking about the high plateau and up in the high corries. So we're actually looking maybe sort of 300 to 400 meters above the level of this. So we're looking there at 30 knots of wind, so about 35 mile an hour. So probably looking something more like 40, 45 mile an hour kind of winds across the kind of the high plateau region at this point. So these are the conditions that we had on the 29th of November. Mark, talk about the
Yeah, so great. So first snows of the winter arrive, and that's quite fundamental for us because the bottom layer on the ground really is the base layer for potentially the rest of the winter. And so what's happening here, the significant thing for us, part of that chain, if you like, of that pattern that we're starting to recognize is this largely fell with very little wind. And that is quite significant from our point of view, and also in terms of crystal growth. And I'll explain a little bit more, but we have a blanket cover of snow. It's very loose and unconsolidated. And there's two things that may happen. It will either remain cold, and so that will stay loose, or it'll be warm, in which case it'll start to bond. All those grains will start to knit together and bind and become more compact, if you like. So for us, we see this happen. We want to know what's going to happen next.
So let's look to the next day then. So on to the last day of November, so 30th of November. So 30th of November, and we basically see kind of on the chart there, basically the very similar pattern to what we had before. So we're still getting that feed of easterly winds. You see on the radar imagery there, still getting plenty of showers kind of coming in around the coastal regions. But we notice there, just a little bit up over the North Sea, those isobars starting to widen apart, and that's indicative of those winds going to be kind of easing off as we go into the afternoon period. Now the thing about this area that's being brought across Scandinavia is what we call a polar continental air mass. So this is kind of often this will often bring kind of very cold wintry conditions through the into the east side of the country. The thing is, as soon as these showers are being driven by the sea surface temperatures, so the relative warmth of the seas, so as they come inland, they start to get cut off, and that's why the showers are really confined to these. Now, as those winds started to lighten off, and we started to basically just see a reduction in the amount of showers coming through. So just a few kind of light showers in this radar imagery there over the Cairngorm at this point, and they tend to die out a bit through into the afternoon period. So this is the kind of a situation we have on basically the end of November. Looking at basically kind of on that thermal imagery there, or image there, we can see kind of a trough bringing those kind of intense showers off the east coast of Scotland, but not really making much progress inland. The other thing we can see as well is the temperatures there, and the pale greens indicate but remaining very cold conditions, increasingly cold. But the winds starting to kind of ease off a little bit there from what we had the previous days. So a little bit less of amount of kind of wind flow. And then as we go into the beginning of December, we can see now basically there's barely an isobar across the whole of the UK. So winds really falling very light. And what we're basically seeing is there's various troughs circulating around the coastal areas, but essentially it's a dry kind of fine, incredibly fine day across Scotland, particularly across the inland places in the Highlands. But as forecasters, our eyes our eyes drawn out to the mid-Atlantic. So cast your eye out into the bottom left-hand corner there. You see it's fairly innocuous looking area low pressure, 1012 hectopascal. Now this is what became kind of quite significant over the next few days. So we were looking at this, and we were looking at the upper air, so high up in the atmosphere around where the sort of jetliner kind of cruising altitude is. And we have a basic river of fast moving air called the jet stream, the polar jet stream. And at this point here on the 1st of December, this was starting to strengthen and sort of dive down south from kind of the western side of Greenland. And this was going to basically start to play a key role in the events that followed over the next kind of few days. So again, just looking at that kind of thermal pattern there on the right, on the left, sorry. So again, we can see a bit of high pressure starting to build, giving that cold, fine day of Scotland. And the winds there kind of going very light and pretty much kind of variable there. And so this is what it looked like on the hill.
Yeah, so snow starting to build up. Temperatures on the surface are around -6, -7, so it's just really, really cold. and you can see there's a really nice blanket of snow covering the mountains. It's fantastic for walking. It's pretty safe, very, very low hazard. Maybe it's about 30 centimeters of depth in places. And you can sort of see -8 on the summits there. That was our observation on the first. And the forecast is little change, going to be cold and clear. So actually, so far, it's all looking pretty good. But what's happening with this snow cover is the stuff happening in that snow. Again, those grains are not bonding together. It's not forming a cohesive layer. It's loose and powdery. And so what's happening there is the grains are not bonding. They're becoming looser and drier. And that's to do with the temperature gradient between the ground and the air. So that's changing the grains. It's not allowing them to stick together.
Well, okay, so going into the weekend now, we can see again there's very light winds from the chart here. So essentially it was a dry day across the Highlands there, so no radar entry this day. So, but yeah, across Scotland, you can even see kind of the vaguest hint of a ridge of high pressure. So actually you can trace it all the way from the Azores high off of Iberia down off of Spain, come across Biscay and France, and up over England, just kind of giving kind of ridging conditions over kind of Scotland, and that was kind of giving us this really kind of stunning day out on the hills there. Light winds, cold, clear. But look out over the Atlantic there. So that little innocuous low pressure, now starting to kind of wind itself up there. So pressure is starting to fall, 999 hectopascal there, and it's starting to kind of the fronts starting to wind themselves up around it there. So starting to see a bit of a kind of a development going on here. And this is the jet streams continue to strengthen as it dives south from Greenland and starts to engage with this kind of area low pressure down the surface. And so it basically draws up this air, looks like a vacuum cleaner drawing this air up, and as it does so, it kind of wraps itself around, and so developing into an area low pressure. So again, kind of cold conditions there, cold, clear, calm conditions, and you see the basically very light winds. So this chart here for midday on the Saturday, and then got also kind of a wind chart here for overnight. So this is valued at 3 o'clock in the morning on Sunday. So we can see here the winds remaining very light, and basically got these clear skies. When you get light winds, clear skies, that allows kind of basically temperatures to really fall away. We get basically a bit of hoarfrost where you get a bit of moisture, so you get a hoarfrost growing. So we've got an example image from a previous couple of years there of hoarfrost kind of growing on the surface snowpack.
Can I just come in on this?
Yeah.
So this really is a beautiful grain. It's a grain that grows up from the ground up into the surface, up into the sky. And how that grows is supercooled water droplets make contact with a cold object and then they freeze. So these grains are actually growing up towards the sky like a bit of a tree. Now, the significant thing about these grains is when they're buried, they are really not great, not good. They're lethal, right? Because they almost stand up like a pack of cards. But additionally, even if they lie down, they're really, really slippy. So as a layer, even if a layer is 1 millimeter thick, that is super fragile and super slippy. Therefore, it's propagate avalanches really, really quickly and suddenly. So already we're beginning to see this on the surface, and we know that there are weak grains in this layer that's covering the mountains. That's the next one, yeah. So yeah, so again, it's not too bad. It's bright and clear. The wind's not very strong, but we've got all this sort of situation developing, and so for us, it's right. Okay, what's happening next? And we know potentially because we get a bit of a heads up in terms of what's going to happen. So already we're being primed into thinking, okay, this is the first of those patterns that we are aware of that actually could potentially lead to some avalanche instability. So already we're wary of what's going to come with the weather system.
Okay, so fine looking day for the weekend there. It's enticing lots of people out, no doubt, I'm sure. And those fine conditions really carried on through into Sunday. So we see over Scotland, at least anyway, still relatively kind of calm conditions, but that low pressure system that was out of the Atlantic there just continue to deepen, continue to be influenced by the jet stream, which is as it's pushing it further west, further east. Sorry, they're coming into west of Biscay now. We can see the just starting to see these tighten the isobars and just bringing in this more of initially a southerly and then a bit later on an easterly flow of air coming over the Scottish Highlands there. That low starts to trap a bit closer in. So essentially a dry day, another fine dry day in the Cairngorms on Sunday. This was the again thermal pattern on the, you can see on the left here. So remember I was saying to you before that this one of the beauties of this wet bulb potential temperature field is it shows fingerprints of this. It's a combination of temperature and humidity, and it can show you fingerprints of where you get the fronts. So I just want to just draw your attention to this plume of just slightly milder, slightly moister air. It's extruding north from the this tropical origins of air that's coming in off the Atlantic, coming up over the North Sea, and this became a little bit significant over the next couple of days as well. Winds wise, it was still very light winds through the day. We can see out over the North Sea what's to come here. So the strengthening of this flow coming up around the eastern flank of that area, high pressure.
Great. Okay, so we've got a bit of wind arriving. It's been dry. That's our observation. This is what we're seeing on the 3rd of December. But we're actually with the forecast. We've got winds are going to be east-northeasterly, and they're becoming a bit strong overnight. So that really is our scenario that we're not really wanting, because now we're going to get snow moving. And we had the Cairngorm Plateau. We saw pictures of the Cairngorm Plateau. Now that Cairngorm Plateau is a reservoir of snow, and if you have 1 centimeter of snow in a square kilometer and that moves, that's 10,000 cubic meters of snow that will move. So if there's a lot of snow, 30 centimeters, and there's a wind, vast quantities of snow will be shifted by that wind and be deposited in places. And the key for us now is the wind is starting to move and lie on top of those weak layers that we've already identified before. All right. So what we have here is moderate, and you think, well, why isn't it more? Because it seemed quite sensitive. But the reason it's moderate, because if you go back to what I said before, the places where you're likely to trigger an avalanche, it's not that extensive yet. Right, it's only these small localized places, maybe in the tops of corries and so on. So it's starting to develop, and we're seeing these problems starting to pop up, saying that okay, there's wind slab, there is weak layers underneath, and also potentially cornices starting to develop.
Okay, so the Monday all change after a fine, calm, blue skies weekend. So see both in the chart and also the radar imagery, and there's a really very different picture now. So that area low pressure is now bottoming out somewhere around 991 hectopascal. So it's dropped quite considerably from where it was initially in the mid-Atlantic there. And we can see in North Scotland, or the Cairngorm, sitting on the northern flank of that, we're basically getting that feed of increasingly strong easterly or east-northeasterly winds feeding in around there. So and that feeding in frequent showers, and then maybe occasionally longer spells of snow into the up into the eastern side of the Scotland and over the Cairngorms there. Now recall that was a plume of slightly milder, moister air we saw extruding up over the North Sea. You can see here a sequence of these images. They're midnight on Monday there, 3 to 6 a.m. midday and 6 p.m. down in the bottom right corner. So you can see this plume starting to move westwards, back across across the Scottish Highlands there. At 6 in the morning, just starting to come into northeast Scotland, and this plume of slightly milder, slightly moister air coming across Scotland, and that'll play a bit of a significant role with the snowpack as well, as we'll come to see. Into the afternoon, and that cleared away. We're back to slightly cooler conditions coming in behind that. So here, basically, got a little mini animation here of the winds. Again, the model winds through the course of basically Sunday night into end of Monday. And so what we can see here is that initially quite light. There's winds really picking up as an easterly and coming into less than northeasterly through the course of Monday before, we can just start to see at the very end there, just to start to the stronger winds starting to edge away there. So this is yeah, so it's often models will underplay the strength of these winds kind of coming in over the top of the hills there. So as a forecaster, we were going to advising the avalanche guys that particularly over the Cairngorms, let's see slightly kind of stronger winds in the models, or maybe indicating there. Great. Thanks.
So the mountain conditions, again, it's still, we've had those winds, we've had wind types starting to develop, lighter this next day. But still, we've got an avalanche hazard of moderate that we've observed, and we've got an avalanche hazard of moderate the next day. So what I'm just showing you here is a slide of, here we have a snow profile, and this really is, we dig a hole, we look at the snow, and we feel how dense the snowpack is. So we look here, this is a knife, pencil, one glove finger, 4 fingers, fist. So we just push, you know, we work out what the density is using our hands. And here we have the temperature gradient. Here it's 0. Ground is always generally 0. The air temperature at this point is sort of -3. But you can see here it's quite a strong gradient. What that means is that when it's at this sort of angle, the temperature and so on, the processes that are taking place in the snowpack are actually not consolidating, making it weaker. Okay. So in here we have, you can see it's 4 fingers, so you can push 4 fingers in there. Here we have a layer which is quite firm, hard, and that was created because of that warm plume of weather that came through just for a few hours in the day. Now that's really quite significant, because what that does, that plays a really not a bad part, if you like, in the development of snowpack snowpack development. Vapor is the sort of tool or the ingredient, if you like, to make grains change shape and grow. They sort of leapfrog to one another, and a supercooled water vapor will make contact with a cold object, and that will grow into a shape, right? So what we're getting here is the grains are this shape, the square, okay, the facets like diamonds, like sugar. Here we've got V, an upside down V, that is circus core. So already we're seeing these grains being preserved in this pack. And with the vapor coming up through the snow, hitting this layer, that's almost like a vapor barrier. And so what tends to happen, we get a lot more rapid growth of these grains underneath this vapor barrier. So although now it's not really significant, you can walk around in it and you can just puncture through this layer, it's not really that significant. Again, it's something else that is this chain of circumstances is sort of increasing to make it a worse and worse situation. And up here on the top left, you can actually see some of the grains, like probably a load of mush, but actually when you on the plate, they will be quite loose and dancing around on these metal plates that we have. And you can sort of see they're square, they're not shaped like a snowflake or a snow crystal. They're actually different types of grain. They've not fallen out of the sky, they've grown in the snowpack. Okay.
So on to the 5th of December. So see here that low pressure now, it's no longer being engaged by the jet in there. So it's past its deepening phase. It's now what we call a filling feature, so the pressure is starting to build there as it moves away kind of over into the low countries. And so when these low pressure systems start to kind of fill, then basically we're going to see those winds starting to ease off. The other thing we can see as well is up over Greenland, got the Greenlandic high there, sending down over Iceland, and extending all the way down in towards kind of Scotland there. So Tuesday, the 5th of December there, another kind of after that kind of bit brief kind of slightly stormy interlude. It's basically turning back to another fine, dry, sunny, very cold day. So you can see the thermal imagery there, kind of again, sort of returning to kind of slightly colder conditions, and those winds kind of easing off as the kind of the strength of those winds continue to pull away. So we're left with another fine blue skies cold, crisp day with light winds on the 5th.
So although we've got light winds, we're now starting to get this wind slab being blown around and accumulating, not everywhere, but just in really specific places in the tops of corries. And you can see but lower down, it's it's beautiful. We've got inversion. It's obviously a really cold day, but things really are starting to develop here. And so I'll run this in a minute. So this now is the snow profile, and you remember this is what we had the other day, and we had these grains, these passive grains, and some surface ore in there, and we had this crust on the top, that barrier. But now you see we're starting to get this wind slab building up on top. So that is overlying this incredibly weak layer in here, right? So what I thought, right, okay, now it's important to tell people what's developing, right? And so decided to put out some images and some chat. So let's see if I can technically get this sorted. Again. Hear me okay on that sound? Yeah, thanks. Okay, so that's the situation now. We've got it, avalanche hazard developing, and forecast is the wind is it's going to be cold, but the winds are going to increase in strength, gale force southeasterly. So what that means is we already have a localized hazard accumulation of wind slab, but it's going to increase in its spread, and therefore we raise the avalanche hazard to considerable. So this was the first avalanche report on that day that I was producing that little video there. And this is, you can see, just above the Larry Grew, and it was reported that some ski tourists, they'd observed somebody descending from Ben McDewey into the Larry Grew, and they'd seen an avalanche be triggered. A large avalanche, even though it's a very small location, it can produce quite a an expanse of snow that to go down. So actually, because there was uncertainty, because there was thought that someone might be buried there, there was actually a rescue went to that location with helicopters and crews to actually see if there was indeed people buried. So it had been witnessed that it had been triggered by people. So that's the first incident on the 5th of December.
Okay, so on to the Wednesday, 6th of December. And again, looking at the chart here, so if you recall that previous chart, we had that area high pressure was building down from Iceland and across Scotland. And we can see that's continued to build overnight through kind of Tuesday night. And then much of, okay, well, looking at the chart, it looks like maybe pretty horrendous stormy day to come. There's pretty much the entire North Atlantic kind of subsumed, kind of covered by this kind of really complex mess of a multi-centered low pressure system. But for Scotland, much of the day actually was kind of weather-wise, it was generally quite fine. Clear skies, kind of very cold conditions. So we're under the influence of that kind of ridge of high pressure that extended from all the way from really the Iberia and France all the way up to Greenland, really there. So can really fine conditions, and this was very, very slow to move in. This was a big kind of complex area, low pressure. Now, often kind of where you get these areas of high pressure forming, particularly over the North Sea area, and this is just a little bit to the east of where the kind of Cairngorms are, or the main hills in Scotland. As forecasters, this is a bit of a kind of alarm bells for us, particularly when we're talking about wind speed. Because what happens as you go away from that area of high pressure, you get basically what we call a bit of a temperature inversion often forming. So which is basically where the temperature, which normally falls away with height, will actually kind of increase just momentarily for height. So either a temperature inversion or just very, very stable air. And that means it's very resistant to being kind of lifted up. So basically you can see the air being drawn up around from Biscay and France kind of up northwards. As we start to get these isobars tightening up, so indicating the wind speed starting to accelerate. Now, as they're forced up over the top of the hills, as I say, it's very stable air. This inversion often sits somewhere just a little bit above the tops of the hills there in the Cairngorms, and depending on the shape of the mountain, it can act basically as a wind tunnel because the air can't really kind of punch its way through this inversion. It's like a lead balloon, if you like. If you lift that air up, it kind of sinks back down again. So it results in accelerating the winds over the top of the mountains there. And this is what was happening kind of basically as we went through into the evening period on Wednesday the 6th there. So again, this acceleration of these winds over the tops there. And this again is something the models will sometimes quite spectacularly underdo. So it's quite common to be kind of 20, 25 miles an hour stronger than the models will forecast there. So again, we're advising the Avalanche guys that we're adding on the wind speeds from the models there. But yeah, so again, looking on the left, first of all, then we can see again, for much of the day, though, as I say, it was very cold, and those fronts were kind of well out to the west. So for much of the day, it would have been quite kind of fine conditions initially, anyway, but luring people out to the hill. But then there's that you can see this little animation here of the winds. We see them as kind of quite rapidly picking up through the course of the day, and even more so as we get kind of higher up onto the high plateau region there.
So, as Mike said, in the morning, it was beautiful. The days before, it also been beautiful, which of course is very attractive to people. Oh, you know, they've seen images, they've got a pretty good idea of what people have been doing before. So they're really enticed to go out. So this is the morning, right? And this, we can see that, as Mike says, bit of an inversion, and we can see this sign here, which is a fuzziness of cloud above the plateau. For us, that means that the winds start to crank up, and it's a result of the weather impact that Mike has just described. So the wind is really going to start to increase. Visibility right now is good, but that snow is starting to shift and pile in to those places into the northern corries. People may be setting out. We have a considerable hazard for this day, but nonetheless, maybe potentially people are enticed by the sun. They don't quite consider that it's going to change in just a matter of hours. So that was really the situation. So we were out that day. It was a considerable hazard, and yeah. So really, this was the cause of that event that occurred later in the day and started that rescue scenario. People went climbing, they got to the very top, an avalanche occurred, person was taken down. Fortunately, they were on a rope, so he was still attached, if you like, but he'd broken his leg and they were incapacitated. So that really started that chain of events. And they were really lucky that the Cairngorm team were up there, who were able to go and rescue them, really. Otherwise, it might have been completely different circumstances. So, yeah, so there again is that profile, and you can see there's that layer that we had down and other profiles, and you see we're getting much more snow being loaded on the top. It's quite hard, it's sort of pencil layer, but we have this layer in here which is, you can put a finger in. So all this dense hard snow is lying on a weak layer, and really it's that released when people went into that zone where this instability was present. And so here we are, where the avalanche occurred, in the top of the corrie here. But for us walking around, actually, it doesn't always, you can see these things, you can make these observations when you're traveling around. And in particular, when you're seeing underneath your feet, you're seeing cracks. The top layer is fairly compact, but it's fracturing underneath you. And that is a really clear sign that there's instability underneath the snow surface there. And okay, where we're moving around, this top layer is only that thick. But if you go higher up into the mountains where the snow's been being pushed and being blown by the wind, that'll be even thicker. So the clues that you pick up low down are really relevant for when you go higher up, right? So that's really important. But with the weather forecast, the wind, all this sort of circumstances leading up to this point, then actually it's fairly clear what's going to happen. And how the snowpack is evolving and becoming weaker, presenting us with this hazardous situation. So I think that's. Do you want to talk about it?
Yes.
So, yeah.
So what we've got here is just basically the weather data that was recorded from the automatic weather station on the summit of Cairngorm. And it was quite nicely illustrates the whole kind of sequence and evolution of the events. So what we're looking at on the top there is we've got the maximum hourly wind gusts, and then on the bottom there, got basically hourly temperature from Cairngorm summit. So we can see from the 29th right through to about sort of the morning of the 3rd, generally kind of the winds falling away, quite light. Temperature's very cold, really kind of -6, -7 at that period. All started to change really from the 3rd. And now a bit of an increase in the temperature, but don't be fooled, it's only 2 degrees. We're still looking -4 Celsius, so still quite cold. But there's winds really ramping up there through the course of the 4th and into the 5th. And that was that little low pressure system that went to the south. Then that kind of lull in the winds, that ridge condition coming in, just tempting everybody out. And then again, so there's ramping up the winds quite rapidly up to kind of into the high sort of 50 knots, so kind of into 60s, high 60s miles an hour to the summit there. We can see the initial avalanche on the 5th there in Dewey, and then it's the other we looked there that we saw the video of basically occurring as the winds are ramping up there.
Okay, thanks. Okay, so in summary, then hopefully that gives you a bit of an insight into how everything all connects and how one thing leads to another, and this situation where we had the avalanche was actually a classic pattern of the development of the snowpack to a point where it becomes quite weak, and everything lined up to produce this situation. It could easily have been within that chain of events. It could have been warmer. The wind might have been different. It could have come maybe from a more of a westerly, moist weather system, which would have changed everything and made everything more stable. So that's why it's really important to just keep note of all these things that have started piling up next to each other and can give us a situation that we had. Finally, though, that avalanches are rare, right? They're extremely rare, but and so that was 2023. The avalanche, we didn't have any last winter. This winter, it's been fine, mostly benign. But nonetheless, it's those rare events that have significant impact, and they also, the media. It's quite, from a media point of view, an avalanche is quite a story. So they do get quite a lot of coverage in the press and so on. But hated to say, rare events, but just be mindful. And mostly we have fantastic times in the mountains, and yeah, enjoy yourselves. It's been really good. So Mike, do you have a
Yeah, thanks, Mark. So hopefully this talk has illustrated some of the just how interconnected the weather and the snowpack is, and then that kind of that risk of avalanches and the hazard there, and how it's not really good enough just to glance at the forecast the day before we go out. But when we go out in the winter, you really want to be looking kind of several days ahead, just trying to understand kind of how that kind of situation is developed there. So yeah, as I say, it's a great pleasure and privilege to be working alongside Mark and the other guys and within the Scottish Avalanche Information Service. And yeah, so I think it's a really good partnership. We've really evolved over the course of the years. So yeah, I think yeah, enjoy the health, stay safe, and if anyone has any questions, we're here to answer.
Thank you very much.
Thank you both. It was fascinating. Well, enthralled and see told that story perfectly. So from start to finish, that was really nice. Got time for some questions. I'll just start off with a very quick one because I thought I knew a little bit about it, but I was even learning all the way through it. The importance of the layers in the snowpack made really clear, Mark, and that was, and then you talked about the impact of the winds moving the snow around. How much in that, I guess if you've got your nice layers and you've got an idea of what the pack's doing in the forecast, if you then get that wind over the top of it, does it just mess up the whole layering, or is it quite isolated on the top?
It depends where the wind will erode snow. And so the places that we are getting the hazard buildup are actually in wind sheltered places. So it's eroding from one place and depositing in these wind sheltered places. And those layers just piles on top of those layers. So that's why it was quite specific in terms of where the avalanche hazard was. It was really quite limited to being only 20, 30, 40 meters below Curry Rim. So it's quite isolated, but the snowpack structure and the strata was preserved in those places.
Yeah, but thank you. Any questions from the floor? Again?
Yeah, I just wondered what happened going forward. When did that become safe, if you like, rather when did that risk go away, or was it always there until you had a major thaw or something?
That's a good question. Yeah, you need a thaw. You need those top layers to maybe be impacted by warmer weather conditions, and that will then eradicate that weak layer. But that's why we call there's an avalanche problem. It's called persistent weak layer. Now they can be preserved. So you can have a cold snow and a temperature gradient can be buried with the snow on top. So actually it takes a long time for that to disappear. And that's why we call it a persistent weak layer. And they're really quite difficult and challenging when you're going into the mountains if we have a persistent weak layer that's there for a significant amount of time. And sometimes we have had avalanche events where that weak layer has been there for maybe a week, 2 weeks, and so on. In other countries, in colder climates, they actually date those layers. So you might have an avalanche that occurred in March, and they'll say it went on the January 15th layer. So that's a persistent weak layer. See what I mean? So we don't have that situation, but what we do have is super rapid development of these weak layers over a 24-hour period because of the warmer temperatures, sort of -4s, -3s. You get very rapid vapor movement and very rapid grain growth of those weak layers. So that's for us, that's our challenge, is this rapid development of these conditions. And indeed, it's something that is now occurring more and more in the European Alps, the weather systems that we're getting now, which is this constant fluctuating types of climate from cold to warm, which is what we're fairly used to and we're sort of prepared for, they're not prepared for it. The winds, the temperatures, the freezing level going way up to 4,000 meters, the 0 degree, which is highly unusual, is having a real significant effect on the snowpack in the Alps now. So yeah, for us it's a challenging environment because of that rapidity of change. Sorry, that was a very long-winded answer to your question. Hopefully it answered it.
Yeah.
I'll come to you in a second. Gary, do we have questions online?
Yeah. Fiona, is there any idea of what percentage of avalanches are observed?
Yeah, that's a good question. Obviously, they're only observed by the people who are in the mountains. So it sort of gives an indication from one year to the next that in terms of the number of observed avalanches. But in terms of the total number of avalanches that occur naturally, it could be double that number. Sorry.
Yeah, thanks, Greg. It was really just following on from the answer to your first question there, what do the change? Obviously, climate change is a big issue of the day, and we're seeing a lot of water issues, fire issues because of changing climate. But are you noticing an impact on avalanches? I know you said you're seeing a slight difference for the Alps, moving differently there. But are you seeing in the Cairngorms or in the Highlands in general a change because of climate?
Yes, what we're seeing is this rapidity of change. And Mike can probably come in on the wind speeds. So, for instance, the last snow we had, it changed 20 degrees in 24 hours. Right, from -15 to +15 or thereabouts, something like that in a 24-hour period. So that's what we're getting. In terms of avalanches, most avalanches with people involvement are when it's cold snow. So we have the situation that we just described. You get weaknesses developing in the snowpack, and that isn't changing. That's happening more rapidly. So that will continue to happen, and that's what's also happening in the Alps. You would tend to think of climate change or warming climate is that you're going to get a lot more warm snow. You will get warm events, but that's sort of that's logical, isn't it? If you get a warm event, it will purge. But if there's a lot of snow and it gets warm and wet, it'll just slide away. Then that gets rid of everything. And they're fairly obvious, but and less people do get caught out in them, but much less than those standing on the snow in a cold snow environment and the layer failing in the substrata below. Yeah.
Are you saying that the quality of the avalanches is changing? But how about the quantity of them? Do you have any data to see?
On quantity of precipitation, maybe I can bring Mike in on this one.
Sorry, is that the saying quantity?
Precipitation.
Thinking about the climate change.
Mhm.
So we see that the quality of the avalanches is changing because of the conditions, but how about the quantity of them? Do we have any data to know whether we are having more or less, or are we really lost?
More or less avalanches.
Yeah.
Sorry, I thought the question was precipitation. In terms of the precipitation, we're probably getting the same amount of precipitation, whether it's snow or rain. But in Scotland, we're seeing less avalanches because actually there's less snow.
Yeah.
Yeah, but that lures us into a false sense of security to a certain extent because on the 1st of January we had a quite significant amount of snow. Then it disappears, then it comes back again, and that really is something that we have to be prepped for and be mindful of, and that we have to be more opportunistic in terms of going out into the mountains and carrying out activities. But the challenge is that by doing that, by going out for these rare events that we're tempted to go to places because it's rare, right? And so we just have to be mindful of the conditions, the forecasts, being weather forecasts, and those set circumstances that we've sort of just illustrated here. But in terms of
Yeah.
precipitation,
Yeah, well, obviously within the, and I'll caveat this with, I'm a sort of forecaster rather than a climatologist, but my understanding there, the precipitate obviously with the generally on average warming climate. So there'll be kind of a lot more moisture in the atmosphere, so that it allows for kind of greater precipitation amounts. Particularly over the winter months where we get the kind of the more stormy conditions. And there is also there's a fair bit of debate over this, but I believe there's kind of increasing evidence that we're seeing kind of more what we call blocked patterns. So what I mean by that is that so as I talked briefly about that sort of low pressure that came across, that was driven by the jet stream. And normally the jet stream will often it'll go kind of west to east like a kind of a fast flowing river. And this brings us kind of very kind of rapid sort of changes of kind of low pressure systems, so that we can bring in kind of fluctuating kind of freezing levels, as Mark's saying, kind of rapidly kind of fluctuating freezing levels and precipitation amounts. In a more blocked weather pattern, rather than this fast west to east jet stream, we see much more meridional. So it's like a big meandering river, and that results in very kind of slow moving weather systems. And that also kind of often allows of when we get these sort of more easterly kind of wind flows, this is often as a result of this big meandering kind of a weakening kind of jet stream. And so there is kind of evidence that I think more so over the summer months really, but yes, potentially over the winter as well, kind of sort of more kind of blocked systems, kind of more slowly evolving kind of weather systems.
Any final questions on the line? I'll take one more online.
Somebody asked, Camilla asked, was there a similar risk of avalanche and cold spells January compared to your case study of 2023? Or did it off quickly?
so the question is, was this year similar situation to previous? There was in a way, but we had cold snow, but we didn't get those chain of events where we had an increased snowfall. We did to a certain extent, but not to the same level we had in 23. So yeah, it could have been, but it didn't happen.
Fine, yeah.
Thank you. And thank you once again for our speakers. It was a fascinating talk, and thanks everyone for coming on. One more.
Thank you. And thanks for the jazz music.
Yeah, thank you.
Get it all now.
So hopefully we'll see some of your final meeting of the season next month, in Edinburgh and online. And as I say, please get in contact if you have any questions or suggestions or interest in anything. So otherwise, hope you all have a nice evening.
Thanks.